Hello everyone, myself P.Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. So in previous classes, we are going to discuss about the superposition theorem, Thevenin's theorem, Norton's theorem. In today's video lecture, so I am going to discuss about the maximum power transfer theorem. Okay. So in this maximum power transfer theorem, so we are having the what is the statement of maximum power transfer theorem, and what is the procedure involved in the maximum power transfer theorem, and we'll discuss one problem on maximum power transfer theorem. Okay, so these three things we need to discuss in today's class. Okay, so here first of all, what is the statement of maximum power transfer theorem? So the statement of maximum power transfer theorem is, so in any linear or bilateral network contains one or more voltage sources, the internal resistance is equal to the load resistance. Okay, so here the internal resistance, that is I am taking as internal resistance Ri. This internal resistance is nothing but Thevenin's resistance, that is RTH. Okay, here the internal resistance is represented as a RTH, and load is there, that is equal to RL. These two should be equal in maximum power transfer theorem. Okay, so the maximum power transfer theorem states that the maximum power is transferred from source to load resistor. The Thevenin's resistance is equal to the load resistor, or the internal resistance is equal to the load resistor RL. Okay, here for example, here I am taking the one circuit here. So here I am taking the one circuit. So plus minus voltage is V, resistor is R1, this is R2, and this is R3, and load is RL. Okay, now this main circuit we have to convert it into the equivalent maximum power transfer theorem circuit. So here voltage is there, so this voltage is replaced by Thevenin's voltage. So this is same as Thevenin's theorem only. So Thevenin's voltage, and the internal resistance means R1, R2 and R3. The internal resistance are replaced by Thevenin's resistance, that is RTH. RTH in series with load resistor RL. So this is load resistor is RL, right? Now at RL we need to calculate the maximum power, that is P max. We need to calculate the maximum power of the given circuit. Okay, so here is the statement and the equivalent circuit of maximum power transfer theorem, right? So here also in this maximum power transfer theorem also we are having the some steps here. So here also we have to find out the total number of loops in a given circuit. So if suppose if you are having the 2 loops means we required currents are 2. If it is a 3 loops means the required currents are 3, right? So here in that case we need to calculate the Thevenin's voltage. So how we can calculate the Thevenin's voltage? So here first we have to find out the total number of loops. After that we need to give the current directions, right? That is step 1. And step 2 is we need to open circuit the load resistor. So we need to open circuit the load resistor. Suppose here is the circuit. suppose load is there. So let us take as this is RL, R1 and this is R2, plus minus voltage is V. Okay. So here we need to open circuit this load. Open circuit the load. Now across the given two terminals we need to calculate the Thevenin's voltage VTH. So here for example, so we need to open circuit the load. So plus minus voltage, resistor R1 and this is R2 and here VTH. Across these two terminals we need to calculate the Thevenin's voltage VTH, and that is step number 2. So step 1 over and step 2 also over, VTH. Now the step number 3 is we need to calculate the RTH. Okay, we need to calculate the RTH value. So how we can calculate the RTH? So for the calculation of RTH, we need to short circuit the voltage source or we need to open circuit the current source, and we have to remove the load resistor RL. Okay, so suppose circuit having the voltage source, so we need to short circuit. If the circuit having the current source, we need to open circuit, and also we need to open circuit the load. Then we can calculate the Thevenin's resistance RTH. Okay, if the circuit contains voltage source, we need to short circuit the voltage. If the circuit contains the current source, we need to open circuit the current source, and load, we need to open circuit the load. Now across the given two terminals of the load, we need to calculate the Thevenin's resistance RTH. After that, we need to calculate the maximum power, that is P max. Okay, so here how we will get the P max here. So the P max is, so already we know the Thevenin's theorem. In Thevenin's theorem, so for example, here I am taking the one circuit, or let us take as one equivalent circuit. The equivalent circuit of Thevenin's theorem. So plus minus, let us take as VTH and this is RTH and this is load. Now across this load we need to calculate the maximum power. So here current through the load is IL. So what is IL equation? IL equal to VTH divided by, according to Ohm's law, VTH divided by RTH plus RL is the load current equation, right? Now similarly, the power through load resistor. So here power through load resistor is, that is P max equal to, so already we know the power equation, so V into I or I square R or V square divided by R. So here I am taking the I square R equation. So power through load means IL square into RL is the equation. Okay, so now the maximum power P max equal to, so substitute this IL value in this equation. So we'll get VTH square divided by RTH plus RL whole square into RL is the maximum power equation. Now, so we need to solve the maximum power. So here the condition is, the condition of the maximum power transfer theorem is dP max divided by dRL across load, that should be, this is equal to 0. The maximum power through load resistor, difference of the maximum through load, that should be equal to 0. Here is the condition of the maximum power transfer theorem, right? Now we can substitute this maximum power in this equation. Then we can derive differential equation with respect to RL. Then we'll get maximum power P max. So suppose if we can do this equation, we'll get RTH is equal to RL. Load Thevenin's resistance is equal to the load resistance. Now suppose for example, if we can substitute RTH is equal to RL, RTH is equal to RL in this equation, we'll get maximum power. So that maximum power is equal to VTH square divided by 4 into RTH is the equation. Okay, here is the maximum power equation. So maximum power equal to VTH square divided by 4 into RTH. So by using this equation, we can calculate the power through load resistor. Okay, so now we'll go for the one problem here. So here load RL. So load is RL. So here we are having the source voltage is 20 volt voltage source and the resistors are 2 ohm, 4 ohm, 6 ohm and load is RL. They are given load as a RL. So here also RL. Now through this RL we need to calculate the maximum power. Okay. So how we can calculate the maximum power here? Here also the same thing. We have first we have to calculate the VTH. After that we have to calculate the RTH. Then we can substitute VTH and RTH in the maximum power equation. We'll get the P max value. Okay. So here first of all, so give the current directions here. So these two are in clockwise direction. So required currents are 2. So here I1, first loop current is I1 and second loop current is I2. So this is, let us take as plus minus, plus minus, plus minus and plus minus. Okay. So now we need to calculate the VTH. So how we can calculate the VTH? So we have to remove this load resistor. We have to remove this RL value. Okay. Across these two terminals, we need to calculate the VTH value. Okay. So here I need to draw the circuit here. So plus minus 20 volt, 2 ohm, 4 ohm, 6 ohm. So here we need to calculate the VTH. Here at 4 ohm there is no current flowing here. So current through this 4 ohm is 0, means I2 is equal to 0. I2 equal to 0 means there is no current through 4 ohm. So there is no 4 ohm element. So here we need to calculate the VTH, means VTH through 6 ohm. So here the currents are I1 and this is, let us take as I3 and here current is I3. Now VTH equal to, so voltage drop across this 6 ohm is 6 into I3. So VTH is equal to 6 into I3. Now we need to calculate the I3 value. Here there is no 4 ohm resistor. So 4 ohm is 0. There is no 4 ohm here. Now 2 ohm and 6 ohm. So these two are connected in series. Okay. So here I1 equal to I3. That is equal to, according to Ohm's law, V by R. In the place of V, 20 volt voltage source is there, divided by, in the place of R, 2 is there and 6 is there. So these two are in series, means 2 plus 6. That is equal to 20 divided by 8. So I1 value or I3, that is equal to 20 divided by 8. So by solving these two, we'll get 2.5 amperes. This is I1 value or I3 value. Okay. Now we need to calculate the VTH. So VTH equal to, now substitute this I1 or I3 value in this equation. So VTH is equal to 6 into 2.5. Okay, VTH is equal to 6 into 2.5 means we will get here 15 volts. So this is the VTH, Thevenin voltage VTH, that is equal to 15 ohms, right? Now similarly, so we need to calculate the RTH. So here the calculation of RTH. So here first I need to draw the circuit. So voltage source, and here load is there. Load is RL plus minus. This is 20 volt, 2 ohm, 4 ohm, and this is 6 ohm. Now here calculation of the RTH. So how we can calculate the RTH? So we have to short circuit the voltage source. We should be short circuit voltage source. Voltage source is short circuit, and here we need to remove RL. Then we can find out the RTH value. So here the simplified circuit is short circuit the voltage source, and we have to remove the load. So here we need to calculate RTH. Okay. Now the elements are 2 ohm, 4 ohm, and this is 6 ohm. Right. Now simplify the equation. So RTH equal to, so here this side we need to calculate the RTH. So we have to start from the opposite side. So 2 ohm and 6 ohm, these two are connected in parallel. This parallel combination in series with 4 means 2 into 6 by 2 plus 6 plus 4, that equal to 12 by 8 plus 4. Then RTH equal to, will get 5.5 ohm. This is the RTH value. But here we need to find out the maximum power. So already we know the maximum power equation. P max equal to VTH square divided by 4 into RTH, that is equal to, so what is VTH value? So 15. So 15 whole square divided by 4 into 5.5, that equal to, so P max is equal to 15 whole square divided by 4 into 5.5. So by solving this, we will get maximum power 10.22 watts is the maximum power answer of the load. Okay. So here, what about the RL value? So the RL value is nothing but RTH only, because according to statement of maximum power transfer theorem, the maximum power is transferred from source to load. The internal resistance or the Thevenin's resistance is equal to the load resistor RL. So what is Thevenin's resistance is 5.5 ohm. So RTH or RL, the RL value is 5.5 ohms. Okay, and here the maximum power is 10.22 watts. This is the calculation of the maximum power transfer theorem. Okay. So here in today's lecture, so we are discussed about the what is the statement of maximum power transfer theorem, and what is the procedure of the maximum power transfer theorem, and how we can calculate maximum power calculation in maximum power transfer theorem. Okay. So in next lecture next video lecture we are going to discuss about the compensation theorem. Okay, so thank you one and all.